Welcome to the MIT Enterprise Forum of the Northwest program on 3D printing. My name is Jimmy Gia. This is our third in a series of 5 programs on these technology leadership pieces, and so we're very happy to have this panel of experts here on 3D printing. The MIT Enterprise Forum is part of a global network of 28 different chapters, and we are the second largest, and so thanks for helping us make this the largest in the country. We'll beat Cambridge one of these days. And welcome to the Hub, which is a co-working space. And it's a wonderful place, offices upstairs and event centers downstairs. If you look in your programs, you can see some of the other events that are coming up later on this year. First, on January 30th, we have our Mix and Mingle, which is where we recruit our volunteers. And specifically, we're looking for people to join our marketing committee. So please feel free to come to that event if you're interested in helping us with that. On February 6th, we'll be talking about the hunt for talent. And on March 19th, it'll be the next in this particular series looking at the augmented self and wearable computing. Thank you to our sponsors, Frommer Lawrence and Haug, Equinix and Point B. And there's also a Twitter handle for tonight, MITEFNW, which you can also see on the PowerPoints that are going through. And so thanks to the volunteer committee, the planning committee that has put this together. And those are Nat Seymour, who was the team lead, Will Dixon, Vicki Owens, Michael Day, Jan Grainlord, Monica Mendoza, who will be live tweeting this entire event, Rami Shaturi, Shirley Lund, Tom McLaughlin, Jimmy Kwan, Michael Brandemart, Wuzo, and Alicia McKenzie. And so, yes, please give them a round of applause. And so without further ado, let me introduce our moderator for tonight, Ashley. She's going to lead us through this celebration of the technology, probably the best way to put it. She was raised in Ellensburg, and she started by becoming an expert in molecular self-assembly of biomaterials, which basically means she started by raising cattle. And then now, she's a patent and trademark attorney within the additive manufacturing space. So please give a warm welcome to Ashley.
One thing you might not know about Jimmy is that he is a fiction writer on the side. We actually had an extensive geese and chicken collection on the farm. No cattle. Well, I think we're going to get started tonight with our keynote speaker. How you doing out there, Hode?
Hello.
Hode, I'm going to take a quick moment to read your bio out here, and then he's going to get started on our keynote event. After we finish with Hode, there's going to be a brief Q&A for him, so if people have questions, hold them till the end, and then we're going to move in and speak with our live panelists here in the room. So Hode Lipson is a professor of engineering at Cornell University, very close to my alma mater of Alfred University. Hode is a professor and is in Ithaca, which, if you know Ithaca, is gorgeous. He is the co-author of the recent book, Fabricated, The New World of 3D Printing. His work on self-aware and self-replicating robots, food printing, and bioprinting has received widespread media coverage, including the New York Times, the Wall Street Journal, Newsweek, Time, CNN, and the National Public Radio. He has also co-authored over 200 technical papers and speaks frequently at high-profile venues, such as TED and the U.S. National Academics. Hode directs the Creative Machines Lab, which pioneers new ways to make machines that create and machines that are creative. Hode, I'll let you take it from here.
What I wanted to talk today briefly is a little bit about the future of 3D printing. I'll start by, I presume that most of you are familiar with 3D printing. If you look at slide 2, basically a process that prints objects layer by layer. Most of you are already familiar with 3D printing. You've probably seen 3D printing in various kinds. On slide 3, you'll see a sort of a plastic 3D printed object that I often carry around with me. It's printed in nylon, and it's about 15 years old. It's actually a pretty old technology that's been around for a while. Slide 4, you can see a part printed out of stainless steel. It's part of a motor. It's a motor impeller, and it's a solid stainless steel part. And most people are familiar with plastic printing, but are not familiar with metal printing, and it's a technology that's very viable and can go and do a lot of interesting things. So where is the technology going? So slide 5 is sort of where we hope the technology will end up, in sort of a science fiction machine that can make almost anything. But really the technology started a long time ago. Slide 6 shows some of the earliest prints back in the early 80s. And as you can see, the technology was actually quite advanced back at the time. These are fairly accurate, precise objects printed using stereolithography technology more than 30 years ago. So technology has been there for a while. Slide 7 is a sort of trend of where things are today. And you can see that there's sort of, in the last couple of years, even though technology has been around for 30 years, there's been this sort of big trend in the popularity, the awareness of the technology. And one of the big questions is what happened in the last couple of years that made the technology so widely recognized. And so so there's a couple of different factors, and I'd like to highlight two. One of them is sort of the popularization of the accessibility of the technology itself. Slide 8 shows a sort of a series of machines. The early machines back in until about a decade ago were very accessible, very expensive, out of the reach of most people. But a couple of years ago, around 2005, slide 9, a few of the first open source systems were released, the Fab at Home and the RepRap. These in turn led to sort of the MakerBot and a whole other genre of machines that are low cost, hackable, and sort of that spurred the consumer scale 3D printing. Today, slide 10, you can see that consumer scale machines are sold more than industrial scale machines. And although they don't account for a large portion of the market financially, but in terms of numbers and in terms of awareness of this technology, the consumer scale machines have really opened the door to the broader public. And I think that many of you first heard about this technology because of these sort of open source systems. But the other factor that made the technology sort of take off in the last couple of years is the broadening of the range of materials that can be printed. So slide 11, you can see a range of plastic materials that, and these are sort of the synthetic epoxies that were used in this technology for almost 30 years. But in the last couple of years, the technology has also expanded to titanium on slide 12. Printing in metals, as I've shown before. On slide 13, you can see printing in clay that's actually done at the University of Washington in Mark Ganter's group. On slide 14, you can see printing in wood. On slide 15, you can see some printing in glass. The next slide is work done in Loughborough University in the UK in slide 16, where you can see printing in concrete. These are sort of larger scale objects. Slide 17 shows you some prints in paper. And this is sort of ironic, but the printing process actually deposits and cuts paper and stacks it and glues it on top of a previous layer to make a three-dimensional object. Slide 18 shows you a sort of banana and a grapefruit printed in paper. It's sort of, it looks very real. It doesn't taste very good, but it's still it's pretty amazing in its sort of fidelity. There's also a whole range of sort of environmentally friendly processes. Slide 19 shows a print made in sand, out of raw sand using a process called solar sintering. Slide 20 shows some prints in terracotta. And interestingly, slide 21, also done at University of Washington, is a print of a boat made out of recycled milk jugs. So you can see a whole range of materials, and the range of material expands almost every day. Slide 22 shows some prints in rice flour, and the range continues to grow. And basically today you can print in almost any material that you wish, from cheese on slide 23 to stainless steel on slide 24. You can also print in almost any scale that you can think of. Slide 25 shows some prints at large scale, architectural scale, and slide 26 shows some prints at a small scale. Really, we're talking about microns. So the range of materials and the range of scales is growing rapidly, and I think that's the transition from just printing in prototyping materials such as plastic to printing in engineering materials such as metals, engineering plastics like nylon, really opened the door for this technology from being a sort of prototyping technology to actually a technology that allows end-use manufacturing components that allow it to do a lot more than it used to. So today, the technology is really going into almost any field, including things like fashion on slide 28, and jewelry on the next slide, and even music, slide 30. And I think the sort of music application, instrument application of 3D printing has gotten a lot of press. We've been using it in education quite a bit. Slide 31 shows, for example, a sort of library of old kinematic models, a museum of kinematic models, machines that we have at Cornell. And we are now able to share with the world not just movies and pictures, but also downloadable 3D printable model of these machines, so that anybody around the planet who's interested in teaching kinematics in engineering can basically reproduce these machines and use them for education. There's a huge growth in sort of esoteric type materials. On slide 32, you can see print in live cells. This is a process known as bioprinting. What we've done here is we've taken live cell from meniscus, that's the cartilage of the knee, cultured these cells into in a hydrogel and printed in a new meniscus. Printed this gel into a shape of a new meniscus, and you can see at the top right, if you advance the slide, what the CAT scan of that meniscus was, and that's the thing that we've printed. So I think we'll see more and more of this technology in bioprinting, and as the technology mature, we'll see more and more cell types that can be printed, including bone, and you may have heard also of liver and kidney sort of next, coming up next. But beyond bioprinting, there's also other types of materials. Slide 33 shows an interesting part printed in scallop. This is a fried scallop printed in the shape of a house, and slide 34 shows you what it looked like before it was fried. And slide 35 shows you a bakery, a cookie that we've printed recently. And what's interesting about this is that if you cut this cookie in half, the slide 36, you'll see that it has text inside, printed in a different kind of cookie dough. So it's really, it's sort of a crude example of what you can do once you think about 3D printing as really combining materials of various kinds and doing lots of interesting things. So it's not just about printing sort of plastic tchotchkes as most people first impression of 3D printing, but really printing at all scales, lots of different materials, lots of different fields. And one of the messages that I'd like you to think about and go home today with is, how will this technology affect your field? And like computing, it's not a question of whether it will affect your field. The question is how, in what way. And so the market trends of this technology are very interesting. In slide 38, you can see that if you advance through the slides, you'll see that really the size of the 3D printing market, if you look at the worldwide manufacturing as this globe, the U.S. manufacturing, if you advance the slide, is this purple circle, which is about two is about $2 trillion. The size of 3D printing is only about $2 to $3 billion annually in 2012. So really talking about a very small portion of manufacturing. So it's very important to keep that in mind when you talk about 3D printing. It's not really denting the mass production, but it is growing very fast, and it's growing right now at about 25% per year, a very rapid growth. The next slide, slide 39, shows a sort of recent breakdown of the applications of 3D printing. One of the interesting things is the top left is direct part production. And that means that 3D printing is moving from printing prototypes to actually printing parts that people use, real end use parts. And I think that's a big sign of things to come, because what it means is that you can actually take advantage of 3D printing's properties to make end parts that you couldn't make any other way. While 3D printing was used to prototype other manufacturing technologies, products were still constrained by capabilities of conventional manufacturing processes. But when 3D printing is used for end part production, that really unleashes the capability of 3D printing to make new kinds of products. There's also an interesting trend in the global market of where this technology is going. The US used to be sort of a leader in this area, but Europe and the Far East are catching up. And just to give you an example, slide 40, we published our book in English and in Chinese, and the book is doing a lot better in China. In fact, per capita, it's something better there. It could be that the translation is better than the original, but it could also mean that there's a lot more interest in manufacturing in China. And in fact, there's a lot of research going on there, and the government is investing a lot of money in research in this area and training. So I want to sort of wrap up by talking quickly about the 10 principles of 3D printing and sort of where things are going. And the reason I focused on 10 principles on slide 42 is I think you hear a lot about 3D printing these days, and a lot of what you hear about is these random applications. Somebody printed this, somebody else printed that, and it's difficult to see in these sea of news on 3D printing what is really going on, what are the trends, where is it going, what is disruptive about this technology. So when we were writing this book, we kept seeing the same themes keep coming up in all these different anecdotes about using 3D printers, and we've summarized them in these sort of 10 principles. So I'll go through them quickly, and if you can identify how one or more of these principles affects your field, then you might be able to sort of take advantage of this technology for your own application. So let me go through these quickly. So slide 43 is sort of principle number 1, and I think is perhaps one of the most important ones, and that's the idea that manufacturing complexity is free. So what does that mean? It means that making something complex, such as the objects on the left, takes no more time, skill, effort as printing something that is simple, like the paperweight on the right. It's all for the same amount of material. Complexity doesn't matter. So the added effort or cost of complexity is almost zero, and that is a fundamental departure from most other manufacturing technologies, in fact, for most of human history. So that is the first principle, and that allows a lot of new applications. In slide 44, you can see an example of a part, an aircraft part produced by Airbus in the foreground that is much lighter and just as strong as the original traditional part in the background. And the part in the front is much more complex, but with this technology, complexity is free, and that allows the part to be a lot lighter and therefore smaller environmental impact, better aircraft performance, and so forth, because complexity is free. Making this part using conventional processes would be very expensive. Second principle, principle number 2 on slide 45, is the idea of variety is free. And what I mean there is that the same machine can make lots of different things. In slide 46, you can see Invisalign braces that are a very successful commercial application that uses 3D printing. And that takes advantage of the fact that variety is free. And indeed, the machine makes a different brace for every person, a series of different ones. And that would not be possible using conventional processes. Principle number 3 on slide 47 is that no assembly is required, which means that you can make things like this chain that are pre-assembled, that are printed as one part. And if you're familiar with conventional manufacturing, a lot of the labor, a lot of the cost of manufacturing is due to labor, and most of the labor is in the assembly. A lot of the errors are in the assembly. So eliminating assembly reduces costs, makes things more reliable. And in fact, on slide 48, you can see a sort of air duct of an aircraft part that used to be made out of lots of parts, but it instead is replaced by a single parts of 3D printing, eliminating a lot of the assembly, making the part lighter, stronger, reducing supply chain, and eliminating fasteners and part counts and so forth. Huge impact to manufacture because we eliminate assembly. Principle number 4 is this idea of zero lead time. So the lead time is the time from the point you have the design to the point you start manufacturing. Most manufacturing processes, there's a huge gap between when the design is finished and the beginning of production. With 3D printer, that time is compacted, it's almost zero, and that allows you to do things like print on demand. And on slide 50 is an example of rapid iteration through product cycle. And that ability to do this iteration quickly is critical in the competitive landscape. And companies that can take advantage of that zero lead time can move forward faster. Principle 5 is the idea of zero constraints. And compared to other manufacturing processes, this technology has the least amount of constraints on the geometries that it can produce, such as this bench printed in a marble-like material that would not be possible to produce any other way. Principle number 6 is the idea of almost zero skill manufacturing. And although it doesn't take zero skill to use a 3D printer, most people would agree that it takes less skill to use a 3D printer than it takes to, let's say, operate a injection molding machine or to do anything else. In fact, kids are using it in schools and so forth. Again, there's pros and cons here. Slide 53 is an example of the idea that you can print firearms in the 3D printer, and the critical aspect of this is that people with almost no skill, kids and teenagers, for example, can print firearms. So that the fact that you don't need any skill makes, is a sort of double-edged sword. Principle number 7 is the idea that the technology, 3D printing, is very compact and portable. And that means that it can be used in lots of different places. And compare that to a traditional injection molding machine on slide 55, which is not something you can carry around or set up, requires a lot of investment and so forth. This fact really disrupts supply chains and distribution networks on slide 56 because you can use these machines in different locations as they are needed. The 8th principle on slide 57 is a sort of the idea that in some materials you can print with less byproduct, less waste. That's not true for plastic, but it is true for metals, such as these turbine blades that are printed by spraying metal powder into a laser beam, and compared to machining it in other ways. Principle 9 is the idea that you can mix materials to create new kinds of materials. And you can see an example of that on slide 59, where you see a printed heart valve made out of different cell types in order to make hard and soft cartilage for a bioprinted heart valve, something that would not be doable using other tissue engineering approaches. And finally, principle number 10 is the idea of precise repeatability, the fact that you can copy things, much like you can copy music, you can copy three-dimensional objects, and that connects the virtual and the physical in a way that was not possible before. And I say that 3D printers are the ultimate manufacturing process that sort of connects to computers compared to other manufacturing processes. That leads to a lot of interesting possibilities. Slide 61 shows an example of 3D printed cuneiform tablets, ancient. They're about 3,000 years old. You can see on the left, you can see the original one. On the right, you can see the scanned one that was scanned in the archaeological site and printed remotely. And you can see how that sort of ability to replicate things can open the door to a lot of interesting possibilities. So, slide 62, I want to end with this question of where this technology going next. So all of these things are happening now. What's going to happen next? And it's very difficult to predict, but I want to break it up quickly to sort of short term and long term. So in the short term, it's very easy to predict that machines are going to get faster, cheaper, and better. Better resolution, stronger materials, lower cost. And most of the 3D printing companies are working already in a lot of these things. A lot of sort of aspects of the technology will improve over time. Slide 63 shows sort of the surface finish problem of 3D printing, that it's Achilles heel, and a lot of people are working on that. Slide 64 shows some technology, for example, stuff that we've been working on feedback-based 3D printers that actually watch what they are printing in order to print better and learn, and so forth. But let me focus on sort of the longer term direction of 3D printing. And slide 65, sort of a illustration of this idea that really this thing is going to happen in 4 stages. And let me tell you quickly where we're at. So episode 1 today is where we're at. And slide 67 is demonstrates this idea that we can print any shape. And that's again, this is where we are today. Technology allows us to print any shape that we can describe to a computer. And that's a big deal, big departure from most of human history, incredible freedom, but it's just the first episode. But it already introduces a lot of challenges because we are not keeping pace with our design tools. Our design tools are not capable of describing shapes that can be manufactured. So today our manufacturing ability far exceeds our design capabilities, both of design software and our ability to imagine and describe shapes. And so there's this big gap. And I think in the future, we'll need design tools that will allow us to design things much better. For example, slide 68, if we're going to design a bracket of a shelf, we'd like to have the computer design it for us automatically. And so there's a lot of things that have to happen now with design automation and for software to catch up with manufacturing so that we can design things like the bracket I showed you earlier in slide 69. But after that, what are the next episodes? So episode number 2 on slide 70 is the idea of new materials. And what I mean by that is that 3D printers will move from sort of single material to multiple material. So slide 71 is the idea that you can combine multiple materials in the same print. And slide 72 is an example of a multi-material print, a sort of robotic ripper that we made that's printed of hard and soft material, printed in the same print job. And that's a little bit like moving from black and white TV to color TV. The ability to combine materials together really allows us to do a lot of things. But most importantly, it allows us to create new kinds of materials. So slide 73 shows an example of a strong, stiff nylon material printed into sort of this kind of mesh material that behaves like a soft sponge. So even though the base material is hard, the ability to print it into a lattice allows us to create a new kind of material with different mechanical properties. So the printer itself is creating a new mechanical property. The same material you can use to print a soft fur-like material in slide 74. Same hard nylon used to create something that's soft and feels very much like fur. Or in slide 75, the same material again is used using a different pattern to print a sort of cloth-like material. So the printer itself, by combining the same base material into different geometries, can create different kinds of material. And you can even combine materials to create gradient materials on slide 76, patterned material, and lots of really, really interesting things. For example, slide 77 shows a material that is sort of self-healing. It's like a zipper, like a two-dimensional zipper that you can rip apart and push back together, and it's like it never broke. So sort of like a self-healing kind of material. The third episode is the transition on slide 78 from passive materials to active materials. So what I mean there is the moving from printing something made of plastic or metal to actually something that's made that contains electronics, power, and so forth. And for example, slide 79 shows an example of a 3D printed battery that we've printed in the lab. And slide 80 shows an example of a printed actuator that bends when it's connected to the battery. In fact, slide 81, this is something that we did just a week or two ago, is a 100% 3D printed loudspeaker. Both the membrane, the shell, the magnet, and the wire inside the coil were all 3D printed. And we were able to play music on this loudspeaker. There's a movie on our website if you're interested in seeing that. And I think this is the first 100% 3D printed consumer electronic device. Now, it's a very simple device. In fact, it's not a very good loudspeaker, but it is 100% 3D printed. And I think this is where things are going in the future, where we'll move from printing passive things to actually printing things that are active. In slide 82, you'll see an example of a embedded circuitry inside a 3D print and so forth. Where we're going with this is really to print a complete working robot that can actually one day might be able to walk out of the printer, batteries included. So far, we've been able to print something that is a lot simpler, such as slide 84 is one of our 3D printed fish robots and so forth. So let me end with this big question that everybody is asking. Is this a trend, slide 86, that will go away, or is it really here to stay? In fact, slide 87, the Wall Street Journal said that this might be a hype, and Forbes also questioned this. So I think that this is really something that's going to stay. And the reason is that, like many other industrial revolutions, this particular technology changes the landscape of manufacturing, because something that used to be expensive is today free. And I think that will change our ability to make things forever. Thank you.
Professor, thank you very much for joining us tonight. I know it's getting pretty late over there, and we are running a bit over here, so we're going to let you go. But thank you again for that great presentation, and especially all the wonderful slides that are allowing us to see some of this 3D printing in action.
Thank you. It's my pleasure. And if anybody's interested in these slides, just send me an email, and I'll be happy to send you the slide deck. Thank you again.
Thank you very much. All right, folks, thank you again for coming tonight. We're going to jump right into the panelists, because I know we're running a bit over time here, and I want to make sure you get a chance to meet everybody and ask your questions. I'm going to lead with a few questions that I discussed with the panelists earlier, but a majority of the time is actually going to be dedicated to your questions. So everybody gets one. There's a lot of you out here, so plan ahead. I'll give you about 10-15 minutes of talking with these guys before you jump in. So let me introduce you to tonight's folks. All right. First we have Ivan Owen. Any of you who might follow the I Expletive Love Science website might have heard of him and his cohort in South Africa. They are the co-creators of the RoboHand. If you were upstairs earlier, you saw that, a prosthetic device that is pretty awesome. When he's not inventing prosthetics for children, Ivan is a mechanical and puppet designer and 3D printer user. He's been featured on NPR's Morning Edition, CBS Evening News, and the Katie Couric Show. Ivan, tell us something about yourself.
Hi, everyone. Thank you for the introduction. So essentially, my primary experience is with mechanical special effects. Essentially building mechanical devices that go inside of things like monster suits. Particularly, most of what I've built are giant puppet hands, which are linked to the person inside the costume's fingers. And that's what eventually led in my involvement in the creation of mechanical finger prosthetics for what turned into a partial hand prosthesis. And so that's what led me to 3D printing because of its strengths in very customized short-run production.
Great, thank you, Ivan. All right, next up we've got Dylan Oliver. Dylan is the general manager of Fathom Northwest, a Stratasys 3D printer dealer, technical support specialist, and rapid prototyping services provider based in Seattle, Washington, and Oakland, California. So if any of you come up to the Fremont-Wallingford Divide on 45th, you can stop by the offices there. Dylan, you used to have a fascination with some Legos. You want to talk to us about that?
Well, I myself, like lots of kids growing up, loved Legos, and when I was about to graduate from college, I kind of stumbled across this technology in 2005, and at that point was immediately fascinated and infatuated and kind of changed my whole career path to chase that down. So Legos were, looking back, kind of an odd and early example of my love to create, and this is kind of the next best way to create. So.
Great, thanks, Dylan. All right, and next up we've got Chuck Pettis, the brand director of MakerBot. He is also the author of Techno Brands, How to Create and Use Brand Identity to Market, Advertise, and Sell Technology Products. Chuck, you had a pretty big week last week at CES. You want to tell us about that?
We had an awesome week at CES. MakerBot is really the leader in desktop 3D printing, and last week we introduced 3 new 5th generation desktop 3D printers, as well as new desktop, iPad, mobile software, and our digital store that allows people to download wonderful digital files and print them out at home, kind of like the iTunes of 3D printing. And I love 3D printing. I think it's really smart for you all to be here. 3D printing is going to totally change the world. It's the next industrial revolution. Fasten your seatbelts.
Great, thanks, guys. So I'm going to go ahead and get the kind of dirty question out of the way. I know we had talked about this in our dress rehearsal, and one thing we'd really like to clarify tonight, the panelists have asked to speak specifically as to the gun production issue on 3D printers, and would like to dispel a lot of the hullabaloo out there on the market. Guys?
I can start. Sure.
Dylan's all ready for this.
No. Well, I just think it's an interesting and kind of sensitive topic for a lot of people, and in the spirit of dispelling myths, I don't think it's as big of an issue as it's being made out to be in media. People have been making inexpensive and dangerous ways to hurt people for a long time, and a printed gun is just not a great use for the technology. It's not the best way to, it's not the most effective means of going about things, and I just think it shines the wrong light on the industry in a lot of ways, and I just don't want people looking at this technology with a fear factor association, where there's a lot more positive things going on, and there's a lot cheaper ways to make weapons that'll work a lot better, and it's just not a realistic concern in my opinion.
I think I could add to that, because I've also seen a lot of the stories in the media, that one of the things that they usually don't point out is that the folks that have successfully produced a firearm made from plastic, which is the real concern, the undetectable weapons, the machine that they used is not an accessible machine. The kind of printer that I use, which is a desktop printer, cannot print in materials strong enough to withstand the pressures and forces involved. The machines that are of sufficient quality to produce those kinds of plastic parts run upwards of like $30,000. Would that be a good estimate, Dylan? Yeah. So, whereas if you were to get yourself a milling machine, which is a far more commonplace tool, it's less expensive than that. So the kinds of printers that are capable of producing those sorts of parts are not accessible at the consumer level.
Chuck, anything to weigh in on that?
The key thing at MakerBot is we focus on the creativity opportunities you can do with 3D printing, how it's going to change every field, every field of endeavor, and on Thingiverse, which is our database for digital things, we don't allow illegal items like guns.
That's great. All right, now that we've gotten the ugly stuff out of the way, talk to me about some of the really cool spaces we're seeing 3D printing come up in various industries. I know we're seeing it in arts and entertainment in terms of toys. There's been some really amazing medical applications in terms of implants and constructing body parts for uses by med students and doctors. What do you see that's awesome and cool and is just going to blow all of our minds?
I guess I'll start. I'd say probably one of the most fascinating applications that are available now and usable is in the medical applications with surgical planning models. CT and MRI data is all layer-based. Our industry using 3D printing is all layer-based. So the marriage between those technologies is immediate and works very well. It's just the software interchange between them to be producing models from your own CT and MRI data. So that's got huge effects. If you're going into an OR and you can have pre-designed implants already ready to go rather than having to mold your acrylic plates and design when the patient is already open. So you're going to see that much more common, and that's going to breed right into actual printed organs like Hod touched on. Livers, kidneys, basic stuff first, valves, and then it's just a matter of unlocking the potential and learning more about the human body to be able to kind of use this technology to move into other areas. And the complete other side is in arts and entertainment and your video games, movies. A lot of the cartoon movies that have come out have all been 3D printed stop motion animation. A lot of the props in movies are 3D printed. We deal with that a fair amount. And there's a whole array of applications that touch really every market segment.
For those of you of my age, you can remember back to like 1980 when the Apple II Plus came out. And I had a software company back then, and our first software was put on a baggie and put on a cook on the wall. Well, 3D printing is like 1980 and computers and software, except it's bigger than that. It's also like 1992 at the beginning of the internet and the World Wide Web. This is a huge thing that's happening here. And just like Apple worked to get a computer in all the educational institutions, MakerBot has MakerBot Academy to get a MakerBot 3D printer in every school there is. Because what happens is when kids get a 3D printer, it changes what's going on. It's instant gratification, it's creativity, it's the answer to the STEM problem we have in education right now. The best thing I can recommend to all of you who have kids, get your kids a 3D printer, get them CAD software. I'm working with a school up on Whidbey Island. This is an alternative school, and a 10-year-old kid on SolidWorks has designed a rim-driven propeller and printed it out. And these kids are working nonstop, full-time, totally enthusiastic. That's what this society, what our world needs right now, is totally excited, passionate kids, and 3D printing brings that to them.
I think one of the things you touched on there, which is excellent to bring up, is how you're referencing when the internet really came into play and people started to obtain access to that. One of the really exciting things, both in education and otherwise, is especially with consumer level 3D printing, it makes it possible for there to be open source physical designs now. Sort of like what was happening with Linux when it came out, and people collaborating on software, it can now be done with physical objects. So if you have a student in one place that comes up with a particular design, they can work with somebody across the country or across the world to collaborate openly and learn together, even though they're separated by such tremendous distances. So this is another very interesting aspect of the technology.
Yeah, it definitely hurdles language barriers, and it's 3D faxing, right? I mean, you can, if you've got facilities overseas, it's that easy. If you got the same machine in both locations, you're iterating in parallel, regardless of bodies of water. So.
Kind of on that note, we've seen the easier side of it in terms of how to get that content back and forth. What are going to be some of the barriers that people are either encountering now? For example, the question of rapid prototyping, which, for those not familiar with the term, it's kind of the unfinished model, the practice pieces, versus the finer end 3D printing. What are we seeing as some of the things we're still tripping up over?
I think I could start on this one. I think in the immediate future, it's simply access to machines. Even though there is a great library of downloadable and printable designs developing, and there's people that are interested in getting involved in this technology, especially students and younger folks. The challenge becomes, so you've got all these great designs. The question becomes, where do you go to print them out? There are companies that will print things for a fee, but if you have low resources, I think I see that as a short-term barrier, is just having access to this technology so people can start to experiment with it.
Yeah, I mean, aside from the cost, from a barrier standpoint, I think an emphasis on having better broadband and internet bandwidth is huge. The file for data transfer for the formats used for printing can be fairly digitally heavy, so to speak. The software that we use to generate the 3D files, are fairly powerful. So as the computers are getting better and better, we need our internet bandwidth to keep pace. I think that's kind of an issue in our country specifically that needs to be addressed. That will make a big difference. Another big factor to it is going to be the intellectual property component. As patents expire, you see kind of a blossoming of new iterations of older technologies, and that's really what's caused the spike that you're seeing over the last 5 years in this industry. There will continue to be patents expiring that will continue to allow for more and more things to happen. Yeah, I mean, and the flip side to that coin, though, is that you got to have those things in place so that companies are willing to invest the millions of dollars to go after innovating the next and greatest thing. Materials need to catch up. We want to get more production-grade materials. The leaps in material capabilities just in the last few years are phenomenal, and the technology to bring that about continues to get better and better. So, my personal hope, as a dealer and a user of this technology, is that as we see more and more of the lower-cost systems coming about as patents expire, that it will force the innovators and the leaders of the industry to really go after that next level and that high end, and I know they're going after that. So.
The real problem is that hardly anybody knows what 3D printing is. So you've got to see it to believe it. It's not 2D, it's 3D. And so people need to see it, they need to experience it. If we're talking about multiple materials and doing all these incredible things, the fact of the matter is you've got to see it, you've got to learn about it. It takes 3D design to build the parts and design the parts. And so that just sets up a huge opportunity for an audience like yourselves who are super tech savvy, entrepreneurs, super smart. Now's the time, baby. Take advantage of this incredible opportunity. This is bigger than computers and software. Take advantage of it and enjoy the fruits of your labor.
So, kind of in that vein, for the general consumer out there, what is their exposure going to be? What's their point of entry? Because they're not going to be on the manufacturing end so much, designing plane parts and brakes and what have you. I had read some of the reports from last week's CES, and there was discussion about some of the food stuff, being able to print sugar cubes in the shapes of dodecahedrons and what have you. But from a more practical standpoint, what will the true consumer interaction be with these products so that they become something that are familiar to them in their homes?
Well, it's going to be the MakerBot Replicator Mini Compact 3D Printer, $13.75, and a downloadable site where you can download pre-designed, super exciting designs, and that you can print them right there in your house. The kids can have sleepovers, they can print out all kinds of cool things, they can learn about 3D printing, and what happens is when they see 3D printing gets going, they forget the tchotchkes and they go into, what can I really make? They create, they get excited, they get passionate, and that's the problem we have with kids in education these days is they're getting way too passive, they're getting into all kinds of unwholesome things. 3D printing is wholesome, stimulating, and it's perfect for STEM in our education.
Anything from you guys? I think that's awesome. One of the areas I had also seen, which could cause some ruffling of feathers on the intellectual property side, is the idea that consumers may be able to start making replacement parts for common things in their home. Common things that break, like let's say kitchen parts, the base of your blender cracks. You can now print out a new one. Discussing that as a possible home option.
That's good.
Yeah, I mean, that kind of thing will come about more. Again, the materials need to catch up and get better and better for it to really work. I mean, it's great if you can fix a component, but it needs to hold up, right? So a lot of times the things you're building at home, at least initially what's available now, aren't going to be as close as what will be capable in the near future. So, I mean, I think the home market is going to be huge for sure. This technology is not going to necessarily change the way you make a garbage can, right? But it's going to change the way most everything is made. As you go through your day-to-day life, just about everything that you interact with was a prototype first, off of a machine that's doing 3D printing of some kind. Every piece of electronics you interact with was a prototype first. Every automobile, airplane, all these things, when you really start to think about it, it's in everyday life all the time. You just weren't aware of it.
And I do see that there could be intellectual property issues that come up in the future. Maybe not so much with replacement parts, because there's a lot of things, at least in our society, where it's almost impossible to obtain replacement parts for a lot of the things that you have in your house. But I know that some of the things I have seen online in various places are people taking trademarked things like sculptures or figurines that have a registered trademark and they're able to now scan them and upload those. Yeah, actually, no, Games Workshop is one of them. There are versions of their figurines that are now accessible and downloadable, and so that creates a similar problem that it's along the lines of what the music industry had going on when MP3s became a big thing. Now we're starting to see the beginnings of that with physical objects that are copyrighted. So there's going to be some concern as to how do you try to regulate that? How do you go about reining that in?
So potentially there really could be something very comparable to the RIAA and the music industry's enforcement of this. We joke about Games Workshop because the miniatures run about $40 a pop for some of the more complicated things, but 3D technology is now allowing for the design and printing of either those exact ones or your own at a much higher level of detail than traditional injection molding. So one thing that might be a concern in especially the toy realm, arts and entertainment, replication of movie props and what have you, is this idea that people are going to say, why spend $60 to get the key from the latest Hobbit movie when I can print it off my $500 or my 3D printer that only runs me $500 and I can print lots of things off. So do you think this might eventually generate something like an app store for, like an at-large app store for 3D printing? I know MakerBot has got their own app store. Yeah. Do you think there's going to be something on a larger scale, like an Apple version or?
Yes.
Excellent.
You've got all these 3D printers coming out. Now it's a matter of what are you going to print? So the cooler the content, the more compelling the content, the more great it's going to be and the faster the whole thing is going to grow. So that's another opportunity, is the development of content.
Yeah, and the things that are kind of slowing that down a little bit is that 3D scanning technology is really also on this tipping point. That it really allows you to capture digital data from a physical object that then you can port into your 3D printer to reproduce. You're seeing, from an IP standpoint, there's sites online now that are very known spaces to get music and films illegally that have a whole subset now that's about physical objects, and so, it doesn't take much to tweak a radius here and there and reproduce a part that's technically not a one-to-one copy, but is very exactly. So, I think companies are still trying to figure out how to deal with it. I mean, you've seen some automobile companies coming out with files that you can print components that might fit your specific phone. You've got, I think Nokia came out with a printed case that they just put out there as more and more people have printers of their own. It's going to be interesting to see how they control that stuff. I mean, if you're printing it to sell it, that's when you're going to get in trouble. And
I just realized there is a good example of, along the lines of replacement parts, that's something that companies can actually offer replacement parts for their merchandise. I'm using one. It's on my MakerBot, incidentally. When I got the MakerBot Replicator 2, I got the first, when it first came out. After it came out, somebody developed a better internal component for pulling in the filament. But mine didn't have that. So MakerBot released a hardware upgrade where I could use my existing parts to print out the replacement part that made the machine better. So it's a pretty cool model, and yeah, and it was they released it for free. So that's actually a value add that companies can add to their equipment that they're selling to people is, hey, if you have a part that breaks down, you can print it and replace that. So that's a potential positive thing that could come of the content creation.
Yeah. And as materials keep getting better, you can do on-demand additive manufacturing. So, I mean, you might have a product that's been discontinued, and there may be a component that, you don't have the tooling for anymore, but you can still produce that part as it's needed without a heavy investment on more hard tooling for 100,000 units you don't need and you won't sell. So that'll be a whole nother huge aspect of it, is the on-demand additive manufacturing.
I talked to a gentleman just a little while ago who had a car part he wanted to reproduce that's not available anymore. So he wants to design it and then sell it to the people in that community. So this is a way to bring new parts where they've gone out of date.
That's great. All right, so what we've discussed so far has been generally smaller things. Pursuant to the video and an article I had read earlier today, what about large scale? There was an article, I think it was on CNN or Daily Mail today, about the idea of using movable gantries to print entire buildings with 3D printing. Do we think that this could actually affect the way that we build our homes?
In the long term, yeah. I think in the short term, disaster relief will be a huge application for this. I mean, you can roll in with a gantry like a boat lift, and that's got a gypsum extruding gantry on it. It's developed by, I think it was UC Berkeley, Contour Crafting, and you can build homes.
Tell us what contour crafting is for people who don't know.
Yeah, it's really just a blown-up version of, if you imagine a hot glue gun on an XY gantry. It allows you to build up layer upon layer relatively quickly and efficiently with something that's going to be a much more sound structure than you may be able to get in other ways. So that's definitely going to be here very shortly. It's been in development for quite a while.
The University of, maybe it's California, is working with NASA right now to develop ones for the moon that could be printed in 24 hours.
Sure. Yeah, you can. I mean, there's, I think it was a student in Egypt that was using just focused solar rays out in the desert on sand. I think Hode had an image of that. I don't know that he described it much, but it's an open source development that this kid did. I think it was a college student. So if you can sinter sand on Earth, there's no reason that you can't use lunar or Martian, materials. You're not going to put it through space, so you got to use what's already there. You're also going to see this technology in space, creating larger structures. So you don't want to necessarily take the media up into space due to the weight, but if you can get it up there and then produce these structures out in space, you'll start to see that in the not too distant future.
Now, as these potential applications for 3D printers grow in terms of scope, do you guys see that there's going to be some sort of resistance from traditional manufacturers, or do you think this is going to be complementary to traditional manufacturing methods?
Actually, I just went and met with a CNC shop up near the Canadian border today, this morning before coming here, and they're actually bringing 3D printing into the mix of what they're doing. So they see it as something that they can incorporate into what they already have going on to offer more services to their customers, because there are parts that they can produce. They specifically have a metal printer, because they can produce geometries and parts with that are impossible to produce utilizing CNC machining. So at least for that kind of industry where they're doing custom fabrication, it's a positive direction.
Yeah, it's really just another tool in the shed. It's not going to necessarily replace everything that's out there. You'll see it used more in concert with other technologies. It's traditional machining is not going to go away. But you're going to reduce cost and mistakes. So yeah, it's not going to displace all these other traditional ways of doing things 100%. It's going to start to trickle in and then get used more and more, really as a cost savings.
Great. Chuck?
Basically, every major manufacturer in the world is rapidly moving into 3D printing because it enables them to bring products to faster, cut costs, have higher quality, and you can, as you saw earlier, you can do much more complex products, lighter, better. It's basically, I think, going to put a lot of machine shops out of business.
I would say it's a little long-term on everybody being out of business. But what I will say is that these machines allow for time compression, right? If you're a business making products and you can get that thing to market a month earlier by leveraging these technologies, that's huge in sales. And a majority, if not all, and if they're not already using it, they should be, these companies are saving tremendous amounts of money and time, and product iterations to market are just coming faster and faster.
Cool. All right, guys, since there is a lot of you out there, I'm going to actually get the Q&A started a couple minutes early here so that everybody can get their questions in. I believe all right, we've got some folks who are going to walk around and pass around mics, but until they do get those mics passed around, I'm going to start with somebody in the front who's going to talk really loudly. So up you go. Yep.
So this is a question for you. So what kind of legal issues are you dealing with right now, and what are you foreseeing?
For right now, it's still been a little bit on the quiet side, but I think once things ramp up, what we're going to see is a lot of problems in intellectual property. The 3D objects that are going to be printed, there's probably going to be infringement of both patents and copyrights, which will be expressed in 3D end objects. So I think it is going to look a lot like the recording industry, where people are just going to say, hey, you know, I want to get this movie replica of this prop. I don't want to spend the money on ordering it from the Lord of the Rings store, so I'm just going to go ahead and print out my own copy of it, either 3D scan or grab it from some file somewhere. So I think that's going to be probably the most prominent thing. I discussed with an audience member earlier about some concerns with the FTC. As we start to get products that are made for internal use in humans, there's going to be issues as to what kind of grade or quality standards those are going to have to meet. And I think we're going to see the same thing on the machine side in terms of where's the liability if things as they are printed, something breaks, what are going to be the quality issues on that?
Okay.
Right there.
Just a simple question for Dylan. I understand the applications in space or other planets. Could you just be a little more specific about disaster relief? It's not obvious to me what people are using it for, this kind of thing.
Well, what I was referencing was specifically the contour crafting technology of producing temporary living structures, homes, as a disaster relief alternative. Primarily it would be in a third world application setting. You're not going to get a FEMA trailer there. You're going to go in material that's already there and produce disaster relief style homes. And that could branch certainly into more modern contemporary homes. But I don't think it will be used necessarily on as wide of a scale early on.
The great thing about the contour crafting is with the utilization of the movable gantry, you don't have to bring in a lot of more traditional construction things. You can just have this gantry essentially moving from space to space, creating layers from the top up. And with the physical materials on hand in terms of the binding materials or something comparable to cement or cement itself, you can quickly do layer upon layer simply without needing more of the traditional construction methodology.
I have a question about the desktop category. Thanks to MakerBot and dozens of other startups coming out of the open source community, we have this really exciting scenario that we're hearing about today. Recently, Stratasys filed lawsuit against one of the resellers of these desktop printers and claims that they have patents that prevent this technology from being widely used. My question for the panel is, if Stratasys prevails in this, or if they don't, what are the implications for the adoption of desktop 3D printing?
I'm not exactly familiar with the specific lawsuit that you're talking about. I don't know if you still have the mic. Can you explain a little bit more in detail what the issue was? which direction the lawsuit was going. Stratasys was being sued or suing?
They were suing another party.
It probably was surrounding hacking the printers to be able to use open source filaments.
No, this was importing similar products from China.
Oh, okay. Well, yeah. I mean, that would be specific to the dealer. I mean, I being a dealer of Stratasys equipment, I'm not going to be selling other equipment. So I think that's a relatively small issue. If somebody wants to sell other kinds of printers, they can certainly do it. But if they're partnered with a manufacturer, it's no different than an automotive dealer selling some other company's cars. It would still be a breach of their contract, I'm sure. But as to the ramifications of it, I think that's a pretty unique scenario. I haven't heard that a lot.
Yeah, it's going to be hard to know too without knowing the particular patent, as I'm certain that the side being sued is going to come back and say, well, do you actually have a claim on that? Is your patent so over-encompassing that you can claim all these different aspects of invention as your own, thereby thwarting the ability for the entire industry to innovate? Yeah.
Okay, so I was expecting a microphone. So I have a question from our MIT Enterprise Forum meetup. And somebody asked, what do you feel the impact will be on jobs? With 3D printing being introduced and you can do a lot of the parts replacement printing on your own, does that negatively impact the availability of jobs, or does it create new opportunities for new types of jobs?
Desktop 3D printers are job creation machines. They enable people who are entrepreneurs to have an idea, to prototype it, and then actually manufacture it in their home or their office or their business and sell it. So what's happening now is there's hundreds, if not thousands, of entrepreneurs who come up with ideas and who are selling parts out of their house or their small business. And the growth in the economy comes from small business. So the way to think about this is, let's get more entrepreneurs. Let's get more people starting businesses, and desktop 3D printing enables you to do that.
Yeah, and to that point, you don't need to be a major corporation to produce things anymore. With the onset of this crowdsourced funding model, it's really breeding a whole new era in the way things are produced. So this technology just helps kind of grease the machine to allow independents to be able to produce innovative, global reach kind of products.
Dylan, are you saying that even a lawyer like me can learn how to make these things?
Absolutely.
Oh, excellent. All right, so I've got Chris here, who is our mobile microphone, so I'm going to guide him to the next person. Let's see, we haven't gotten anybody in this section of the room, so right here, black glasses, blue shirt.
Are you familiar with metal printing? I was wondering specifically, is it always a powder which is ignited by a laser, or are there other methodologies for transferring the material? And if it is always that way, where you're heating the material with the laser, is it an oxidized form of the element, or can you get pure elements?
I'm not 100% sure on the element portion and the purity. A lot of it is done with sintering, and it's almost all with powders. Direct metal laser sintering, DMLS is the acronym. That's kind of the most common and produces the best, cleanest part right now. It's almost a fully dense part, so its strength is pretty good. It's not like a cast part, but it's very close.
Are there voids?
There are very, very small voids. Yeah. And there's another technology out there in metals called electron beam melting. That's where you're actually shooting a particle into the electron beam diffuse at the point of contact. And that's going to be more of what we call a near net shape. It's going to produce a very solid, fully dense material, but not with the accuracy and precision. It usually requires a secondary machining process to get it back to its final state.
So the voids are random?
More or less, but as the software gets better, they'll be able to control it more. So creating structures with putting in space, putting in air pockets, putting in lattice structures will increase strength while reducing the material used in the print.
And then we control the voids themselves by placing them where you want them.
Exactly, yeah. I mean, right now with the powder-based technology, you can shake out the powder. So you can build in voids and structures, lattice works, to create stronger structures that are lighter than a cast material would be. Thank you.
And then there is another technology that I got to see today, and I got a very brief introduction to it, so maybe you know more about it, where it's a metallic powder that's first fused with a binding agent and then cured in a furnace. So are you more familiar with that one?
Yeah, that was still using powders, but with an inkjet modality.
Yeah.
And then once you get your, what they call a green part, it's similar to what they do with plaster-based printers now, only they're using a metal media, same powder, only you're using inkjet heads to deposit a binder solution that holds the part's form until you can get it into basically into a furnace and bring it to its final form.
Cool. All right, we're going to go back corner here by the pillar, black sweater.
I was wondering about the design tools. What things are easily done with the tools today? What things are hard? And how hard is it to learn the tools?
Could you repeat the beginning of your question?
I'm wondering about the design tools. What kind of things are easy to do? What kind of things are hard? And what's the learning curve for the tools?
I can start with the learning curve. I'd say if you have a background in computer science, the learning curve actually isn't as steep as I would have imagined. I'm self-taught in design, utilizing some free tools that you download from the internet, primarily a software called OpenSCAD, which is a completely free design platform. And within the space of a month, it was possible to start learning how to create simple printable objects, especially since there are a plethora of online tutorials, both in text and video form, that can help to guide people through the process of learning design. So.
Yeah, CAD is kind of the hurdle in computer-aided design. You don't need to be a software engineer to do it. As software gets better and more intuitive, software like Google SketchUp, which is a free software, Blender, which is a free software. Some are easier to use than others, but all can be used to produce basic objects. When you want to get into really complex geometries, it gets to be more difficult. But there's an array of fairly accessible softwares, and there's courses that you can take, even at entry level, to be able to get into producing fairly exciting models. So the barrier to entry isn't too bad.
Chuck, are we seeing some EdTech software in that space? For this, at least for the student end, that I'm certain would still be applicable to the adults.
Well, the kids are using the software that was just mentioned. There's downloadable free software. Autodesk has some free, easy-to-use software, as well as some professional software. There's SolidWorks. There's a lot of software out there. There's a lot that can be done to improve all this software, and that's one of the things that's going to happen over time.
All right, programmers, get yourselves ready to go. Who's up next? All right, let's see. We've got a hand waving in the back, so we'll go ahead.
Sure, I have two questions.
You only get one unless they're related.
Okay, the important one is about manufacturing cost. When is cycle time going to get competitive in 3D printing? I'm making a 3D printed propeller here in Seattle at the Fremont Maker House. And it's a really cool propeller, but it takes 12 hours on the MakerBot to make it. I can get 1,000 made in an hour in Tijuana. When is 3D printing going to make a difference to mass production of the stuff we use every day?
It's going to take a shift in the modality itself, the way the part is produced. Anything extruding a thermoplastic is vector-based. It's got to trace a path. As you get more complexity in your 3D design, time will go up. The inkjet-based software, technology, Polyjet from Stratasys. That's a raster-based technology like your home 2D printer. It doesn't care if you're doing cursive or a photo or block text. It's going to print it in passes quickly. Same thing goes with the photopolymer resins. They can produce complex parts very quickly. Some technologies are just faster than others. Some technologies are better at one thing than another. There's no perfect all-around solution for everything yet. To your point, mass producing tens of thousands, hundreds of thousands of parts, if you need it really, really quickly, injection molding is pretty hard to beat right now. What you're going to see, though, is more using 3D printed tooling, not necessarily printing the part. You'll do that, as a, maybe an on-demand manufacturing solution, but actually 3D printing either in metal or polymers, the tool, the mold that we're injecting into, that's a very quick way to get to short run production, being able to pivot and change designs in line without investing in these large complex tools. So I think early on in the very, very near future, starting now, rapid tooling is probably going to be one of the more disruptive things that you'll see in the industry on the actual manufacturing side.
All right, so vest, and I can't tell the color of your shirt, but Chris is already there.
Hi, I've got an aerospace question. Is there any, for an aircraft on the ground, AOG application where there's a one-off part, is there any thinking about possibly making aerospace parts both in terms of material strength, which sounds like maybe it isn't there yet, and then secondly in terms of FAA certification? Has anyone been exploring either of those things?
Well, Stratasys uses an old TEM material for some of their Fortis machines, so that's an FST-rated material that can actually be used in aerospace applications. It's really going to be more for ducting and things like that, typically more passive systems, but that's in place and can be used now. NASA recently launched a rocket that had, I think it was a fuel mix component, I can't remember which one it was off the top of my head, that was 3D printed in metal. And then they launched that rocket. So, that's a test phase, but they're proof of concepts, and you're going to start to see it more and more often. Whether or not the part is printed or not, I think will matter less, and that's really as the materials continue to improve and the modalities that print these materials get better and better.
Last is back order.
I don't need a mic.
All right.
Oh, we do. Or you do? Okay, I'll wait.
This is all being recorded if anyone wants to distribute it to friends and family later.
I represent the product design firm here in Seattle, and a lot of our clients come to our offices expecting to be able to get into concepts like what Bert mentioned. They have a product idea and they're hoping that 3D printing, because it's so fast and so cheap, that they'll be able to go into mass and supply their customer base with product. There's a hurdle there. I think a lot of the people in this room are entrepreneurs, so can you start to address the difference between the benefits of 3D printing, the speed, all these things, and mass production, bringing products to a mass market? Now, I believe in the educational and very useful learning aspects of 3D printing, but I know as a professional in the industry that there's a very hard line between what you can do with a 3D printer and mass production. So can you address that a bit more?
Yeah, 3D printing has become an integral part of the bridge to manufacturing. Our mantra is fail early, fail often. You want to make your mistakes with the prototypes. You want to find your mistakes early. That's why having this technology in-house is so huge, because you don't want to be delaying decisions or moving into tooling on a hunch that you feel like it's going to work, and then finding the interferences in your machine tool, those $70,000. You want to find that stuff early, and this technology is really about that quick iteration, designing in parallel. If you're a designer and you're waiting for parts, and it takes 10, 15 days depending on the supplier, then you've got to move on to something else, and that diverts your attention and focus to other projects. As these technologies are brought more in-house, they're used and flipped on an overnight, nightly basis, so you're iterating quickly, and that leads to that time compression that I was mentioning, where you're able to make decisions quickly and move to manufacturing sooner, getting products to market more quickly, which is going to generate more revenue for the business ultimately. So it's really a bridge to manufacturing. It's a shortcut. It's a relatively low-cost way to make a lot of mistakes early on.
And then it also has applications in the commercial world for any sort of product that is by its very nature highly customized. In Hod's presentation, where he was talking about the Invisalign as an example, that's a perfect application of this sort of technology, because it needs to be uniquely formed to each individual customer. So for anyone that's developing a product that needs that kind of flexibility, this is an excellent technology to explore.
All right, we're going to go to the front of the room here.
Okay, so we're still talking about time savings, and as a lay person, I'm just looking at the cost aspect of it, and five nexus, for example.
Would you mind just running from the beginning on that one?
Okay, so Dylan, you're talking more about time saving still, and I'm interested specifically about cost. If I have access to a Replicator 2, for example, so that cost is out of the way, What is the difference in cost per item, say of a plastic piece, if I want to produce, say, 100 of them on my replicator 2 as opposed to other manufacturing or fabrication channels with the same type of material?
Well, the MakeAbout Replicator 2 uses MakeAbout PLA filament, which is a corn-based product, and it costs about $48 for 2 pounds. So you weigh what your product is, and you divide that into 2 pounds, and that lets you know how much the part's going to cost. So there are a number of them, actually a lot of entrepreneurs who are doing basically PLA plastic type parts, and they're selling them. And so this goes back to the part production part of it. The metal, the way we traditionally think of manufacturing with metal parts and sophisticated parts, we still have a long ways to go on that in terms of mass production, but it's about really right now for entrepreneurs, try something out. And you can do it on your desktop. You don't have to have a $30, $40, $50, $800,000 machine. You can actually create in your home, in your small office, come up with something new, try it out, sell it on a small scale, and if it pops, then you can roll it out and use whatever manufacturing process would work best for you.
Is it cost me a lot more or a lot less using that filament? Say I want to print 100 of those items, or go to somewhere else, say a fabrication place or a machining place that have produced?
Probably going to be pretty low cost to do it in plastic.
Yeah, one of the things to consider, unless you're going to a facility that offers 3D printing, if you were to be going to somebody to do injection molding, for one thing, they're usually looking at thousands upon thousands of units. If you're just wanting to try out 100, they're still going to charge you the fee to create the tool, the die into which they're going to inject the plastics. So the price on that can be tens of thousands of dollars just to create that die. So, but if you only need 100 of them, then you've just created 100 extremely expensive components. But then, like Bill was saying earlier, but if you're looking at producing 40,000 something, then your costs are going to be lower with injection molding.
I'd just say real quick, I mean, you can produce very low cost parts with these, especially with MakeAbout printers. The question is it going to do what you need it to do as the product that you want to sell on the market? Is it going to achieve the goals that you want it to achieve? Is it going to hold up? Is it going to last? You're going to put your name on this thing and put it out in the world. You need to make sure that it fits the application. There's materials that are going to be better in certain situations than others, and to produce very high-end parts. Right now, there's limitations in 3D printers to do the resolution, the quality, the strength. They're not fully isotropic when they're printed, and it's not the same as an injected part, and the same in all axes. You have better strength in some X, Y over Z. So there's considerations to go into. Not every application is going to be perfect for that, but there's a lot that it is. There's a lot that are perfect for that. To your point, I mean, you could very easily do all your iterations on these very low cost printers, get it to a point where you want to go to that next level, get that part that's functional and show worthy to get it out there and to sell with. And then that leads you into getting the funding to invest in the tool, to get the end use components. So again, it's that shortcut and it's that bridge into manufacturing without all that risk up front. Whether or not it's a service provider or owning your own machine, it's all relatively lower cost than going straight to manufacturing.
All right, here we go.
Yes, question for Dylan. You indicated earlier that there's a weakness in this whole spectrum having to do with the scanning technology, taking a 3D object that already exists, scanning it, and then being able to replicate it with the printer. Okay, what's the best software? Who's got the leading edge in the scanning area these days? Can we take a part to somebody now, have it scanned, and then replicate it using your 3D printing?
Yeah, I mean, the technology is absolutely there. The scanning technology's gotten very good. There are firms that do similar things to what we do, only for the scanning side as opposed to the prototyping side. Well, we can talk later. I don't want to put a bunch of company names out there, but there are, the software component is the most difficult. It can be difficult to stitch these very complex meshes together. The data sets, it's called point cloud data when you scan to recreate the object, create very digitally heavy files, gig plus. which requires a lot of computing power and a lot of bandwidth to transfer the data. So the bottleneck is in computing power, the ease of the software use, and the actual power of the machine that you're running the software on. It's not as quick and easy as we hope it will be soon. And then the software has to be in the hands of the right person. One person can do it much more quickly, than someone else. I'd be happy to connect you with some providers. It's not something that I do personally, but you can absolutely get it done.
All right. Who hasn't asked it? Here we go.
I have a question about product liability. I've made replacement parts for things and I've shared them on websites like Shapeways, and then after thinking about it for a bit, I decided I better take them down, because what happens if my parts fail and somebody gets hurt? The nice thing about 3D printing is we can take amateurs and we can make them into manufacturers, but then also the bad thing about 3D printing is we can take amateurs and make them into manufacturers. Are we going to see a explosion of product liability when amateurs start to manufacture parts and they're shared online and they're printed by Shapeways and on MakerBot Thingiverse? What do you think about that?
An explosion of litigation in the United States over something? Yeah. Now, granted, I haven't really spent much time on products liability since my second year of law school. I am primarily an IP attorney, but yes, I think we are going to see an increase in lawsuits. Anything where a human body part could sustain an injury is going to be something that's going to be the subject of litigation. So I think if people start, especially again with things that are going inside of anyone, or that could potentially involve some sort of external bodily injury, if it's coming off a 3D printer, I do think we're going to see an upswing.
There probably will be a growth in certification businesses that would actually have to, these large corporations that are releasing these products are doing a tremendous amount of testing and R&D before they're bringing products to market. So it may become a necessity to have, actual certification firms, and maybe something like this already exists.
Yeah, and they might already exist too within specific industries. Like I'm certain within various transportation industries, there's got to be quality control measures on the parts going into, let's say, planes. If you have a crash that results from a part being ineffective, there's already probably quality control mechanisms in place for some of these things. But for the spots where there's gaps, and there always will be, we'll see some work for the litigators. All right. Speaking of a lawyer, Alex Medelsky.
Let him go first.
All right.
Is that okay?
First.
So what about printing molds for metal casting? I can imagine, a small run of maybe 10 or 20 parts. You don't want to invest a lot in the mold, but it seems to me you should be able to print a mold. And how would one go about that?
One of the technologies that's available are printers that can actually that print sand, that fuse together sand for that purpose, so that you can create a negative form inside of a block of sand for casting metal. And do any of the Stratasys printers do that, or is that in my company?
No, that's not their niche, but yeah, that technology does exist now. It's relatively new, but it's now viable and on the market, and you'll probably start to see it a lot more. So, to answer your question, yeah, you can do that now.
They also do plaster, no?
Yeah, plaster, we do all kinds of stuff.
I had read, I believe in the Wall Street Journal, that GE was going to be printing turbine blades, I believe it was, for jet engines. So it kind of doesn't seem to mesh with a little bit of what was said about it not being high quality, something that you would replicate over and over. I don't know if any of you know about that, but I'm trying to think of what would be the advantages to GE in printing the turbine blades.
Most likely you would have to do to conformal cooling channels built into the part so that your blade cools itself as it rotates. That's one of the main applications for that kind of stuff. GE's definitely gone full force into metal printing. For a business like that makes so many different things, including jet engines. There's a huge cost savings to be had there if they can use additive metal printing technology. The machines themselves are still very expensive, so it's the barrier to entry with metal is much higher than with plastics. But to your point, it can absolutely produce high-end end-use parts, but the application has to be specific enough that it's going to justify the cost over traditional machining. But conformal cooling channels within fan blades, I'm sure, was the reason for the solution.
Last question of the night. If you could pass the mic up to the man in the center here.
Thank you. So there's two topics that we didn't really hit on that seem to be pretty significant. One is, I've heard, I don't know if this is a real statistic or not, that 90% of a lot of products' cost is in transportation. And if we start printing locally, what does that do to resources and kind of the world? And the second thing, and this is probably a good question to end with, is if we're starting to print body parts and we're starting to print food, what does that look like 10, 20, 30 years from now?
The end of cows.
Which end? No.
Sorry. There's a serious question. To the first point about transportation costs, I'm not sure as to the exact figures, but it is an interesting thing to bring up that if I can print something at home, I don't need to drive to a store, I don't need to have anything delivered to me. This would be something else similar to, well, Amazon was a very innovative idea, having everything centralized in the warehouse, which made it more efficient as far as the distribution of products. So this could definitely, for certain things, decrease the carbon footprint of a particular design or object that the end user is experiencing.
It should keep a lot of manufacturing in the U.S. as well. This technology, as I was mentioning, can be used for, you can create complex parts that don't require the assembly that you used to traditionally have manufactured overseas just due to labor costs. When you get into true mass production, you can get pretty close in the U.S. It's when there's assembly involved that the costs become more difficult to justify in the U.S. But this technology will definitely help bring that more in control and more in the U.S. You'll see it a lot with, due to intellectual property as well. They want to keep things, under their own roof as much as possible. It's going to take a while before all mass production is done here, but this will help contribute to speeding that process up.
So being able to print locally is very disruptive in terms not just shipping, but distribution, all the resellers, all the packaging in between. There's a lot of ramifications to this that really haven't been thought through. But where we're really going is you go back to Star Trek, Picard, computer, tea, Earl Grey, hot. Let's replicate.
All right, guys, how about you each take just a moment to say a closing remark and start with Chuck and work our way down.
This is really an important shift in society and in manufacturing. And for a group like yours, again, I just want to reiterate, this is a huge opportunity. It really is an infant industry. It's an infant beginning revolution. And you all, I want to invite you all to join the revolution.
Yeah, absolutely. I mean, this technology is here to stay. It's only going to get better and more exciting. You're going to see an acceleration in what's next. Things are going to come faster, materials are going to get better. There's a tremendous amount of investment behind this technology, and it's only going to grow. The future for 3D printing and additive technologies is very bright, and hopefully you'll all come along for the ride.
And one of the other things that I think is very exciting and that we will definitely see happening within just the next couple of years, not even 10 years out, is many more people jumping into and joining the design process, the process of innovation, as the way in which this lowers, decreases the barriers to getting into the world of design. So it's an exciting thing to see, both from everyone from the hobbyist to professionals in particular industries. So.
Great. Well, let's give all of our panelists a hand.
informative session. Thank you all for joining, and our next event, Mix and Mingle, Thursday, the evening of January 30th. Hopefully we'll see some of y'all out there.
No, we'll see you later.